Hello everyone, welcome to my channel Regular Learning Academy. I am Dr. Krishna Sarker, Department of Electrical Engineering. Here in this session, I will be going to discuss about state space analysis, direct decomposition technique. This is lecture series on state space analysis, lecture number 9. So our topic's name, state space analysis and direct decomposition technique. Direct decomposition method. A linear time invariant system is described by transfer function of the form. Linear time invariant system or LTI system is described by transfer function ys by us equals to b0 s to the power n plus b1 s to the power n minus 1 plus b2 s to the power n minus 2 plus plus bn minus 2 s square plus bn minus 1 s to the power 1 plus bn divided by s to the power n plus a1 s to the power n minus 1 plus a2 s to the power n minus 2 plus plus an minus 2 s square plus an minus 1 s to the power 1 plus an. This is the linear time invariant transfer function where ys is the output and us is the reference input, and numerator is called zeros and denominators are poles, and in this situation numerator powers and denominator powers same. Normally numerators powers always less than denominator. Direct decomposition method is used when the transfer function of a system is not to factor from. This is the important sentence. Direct decomposition method is used when the transfer function of a system is not factored from. That means s to the power n plus a1 s to the power n minus 1 plus a2 s to the power n minus 2 plus an is not in factored form, then we can apply direct decomposition method. So this is our transfer function. First split this transfer function ys by us equals to zs by us into ys by zs. This is the technique. Zs by us into ys by zs, where zs you cancel, then ys byzus. That means ys by us equals to transfer function left hand side, also right hand side ys by us when zs cancel. This is the block diagram for this technique, where us equals to input and y of s equals to output, and zs by us, this is the first block or first position. So zs by us, this is the first position, output zs and input us. So output by input equals to first transfer function. This is the zs by us. And second transfer function ys by zs. This is the second transfer function. And first transfer function, this is the first transfer function zs by us. Just put zs by us equals to 1 by s to the power n plus a1 s to the power n minus 1 plus an. This is the zs by us. And second term ys by zs equals to b0 s to the power n plus b1 s to the power n minus 1 plus plus bn minus 1 s to the power 1 plus bn. This is the ys by zs. So calculate first zs by us and then ys by zs, and then overall state matrix, state equations, state diagram and signal flow graph, and from state diagram determine the stability of the system. Our development starts with a transfer function of the form. This is the first part. Zs by Us equals to 1 by s to the power n plus a1 s to the power n minus 1 plus a2 s to the power n minus 2 plus dot 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 an minus 1 s to the power 1 plus an. This is the first part. So calculate and multiply, first multiply us into 1 and zs into denominator. Zs into denominator and us into numerator 1. So multiply s to the power n plus a1 s to the power n minus 1 plus a2 s to the power n minus 2 plus dot 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 an minus 2 s square plus an minus 1 s to the power 1 plus an whole into zs. Cross multiplication equals to us into 1 or us. Then s to the power n is into zs. This is the first term. A1 s to the power n minus 1 into zs. Similarly, this is the second term. This is the third term. A2 s to the power n minus 2 into zs. Dot 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 an into zs. This is the last term. And right hand side reference input u of s. The corresponding differential equation is the corresponding differential equation. This is the corresponding differential equation. That means taking inverse Laplace transform. If this equation number 1, then taking inverse Laplace transform, and we get, this is the nth order differential equation. That's why dnzt by dtn plus a1, this is the coefficient, s to the power n minus 1 order differential equation. That's why dn minus 1 zt by dt n minus 1 plus a2 dn minus 2 zt by d to the power n minus 2 plus dot 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 plus an minus 2 d2 zt by dt square plus an minus 1 dzt by dt plus a1 an zn plus u of t. This is the differential equation, nth order differential equation, where u of t equals to reference input. This reference input may be step, impulse, ramp, parabolic, sinusoidal. You can apply any type of input, but z of t, this is the output, and this is the position of the output, z of t. And dzt by dt, this is the velocity of the output, because rate of change of position or rate of change of output, z of t. And this is the acceleration d2 zt by dt2. So output always varies. That's why this z of t equals to state variable x1, and this is equivalent to x2, and this is equivalent to x3 dot dot dot. This is equivalent to xn state variable. So put state variable. This is the another pattern of the nth order differential equation. dn by dtn equals to pn, p to the power n into z dot t, and a1 coefficient, and dn minus 1 dt to the power n minus 1 equivalent to pn minus 1 z dot t. Similarly, dot 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 an into z dot t equals to u of t. This is the another form. Having developed a realization of the simple transfer function, we are now in a position to consider the more general form to get one state variable model of the system with a state variable starting at the right and proceeding to the left, the corresponding differential equation using this identification of state variables. That means just put state variable and calculate the overall state equation. This is our nth order differential equation, where input equals to u of t and zt equals to output. So put position z of t, put position z of t equals to x1 state variable. This is the state variable x1, z of t equals to x1. Differentiate both sides and we get z dot t. This is the zt, this is differentiation term, z dot t equals to dzt by dt equals to x1 So differentiate x1 dot equals to another state variable x2. Again differentiate both sides. For nth order differential equation, put the state variable in number. Then z double dot t equals to d square or d2zt by dt2 equals to x1 double dot equals to x2 dot equals to x3. Again differentiate. Then z triple dot t equals to d3zt by dt3 equals to x1 triple dot equals to x2 double dot equals to x3 dot equals to x4 dot 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 zt to the power n minus 1 dot equals to dn minus 1 of zt by dt to the power n minus 1 x1 to the power n minus 1 dot equals to dot 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 x n minus 1 dot equals to another state variable xn, and finally x z n dot zn dot, that means dn zt by dtn equals to x1 to the power n dot equals to dot 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 x n minus 1 double dot equals to xn dot. So this is the state variable, and differentiate both sides, and we get x1 dot equals to x2. This is the very important part. x1 equals to x2, one state equation. Another state equation x2 equals to x2 dot equals to x3, and another state equation x3 dot equals to x4, and xn minus 1 dot 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 xn minus 1 dot equals to xn, and finally xn dot equals to calculate xn dot, and put here z of t equals to what? x1, and dzt by dt equals to x2. This is equivalent to x3, this is equivalent to x4, this is equivalent to dot 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 xn minus 1, this is equals to xn dot. So put x1, x2, x3 dot 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 xn dot, and we get the state equations. So put xn dot plus a1 xn plus a2 xn minus 1 plus dot 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 an minus 2 x3 plus dot 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 an x1 equals to u of t. This is the equation, and xn dot equals to minus a1 xn minus a2 xn minus 1, just differentiation term left hand side and free of differentiation terms right hand side. So finally the state equation xn dot equals to minus an x1 minus an minus 1 x2 minus an minus 2 x3 minus dot 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 minus a2 xn minus 1 minus a1 xn plus u of 2. This is the state equation, state space equation, because left hand side differentiation terms and free of differentiation terms right hand side. So the state equations are, what is the state equations? So first equation x1 dot equals to already proved x2. This is the x2, and others coefficient x1, x3, x4, x5, xn minus 1, xn and u of t coefficient 0. So only x1 dot equals to x2. Similarly, x2 dot equals to x3, and others coefficients all the coefficients are 0 or without x3. And similarly, x3 dot equals to x4, and others coefficients 0. Dot 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 xn dot equals to, this is the xn dot, minus an x1 minus an minus 1 x2 minus an minus 2 x3 minus an minus 3 x4 dot 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 a1 minus a1 xn plus u of t. These are all states equation. x1 dot x2 dot x3 dot 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 xn dot. So calculate state matrix. These are state equation, and this is the state diagram. Very important terms. This is the state diagram. From equation, first input equals to u of t. So put here input u of t, and what is the output? Output z of t, and z of t equals to what? x1. So put output z1 t equals to x1. For nth order differential equation, put n numbers comparator or n number summing point and n number integration. So again, for nth order differential equation, put n number comparator and n number integration. So first value minus a n x1 minus a n x1, because xn dot integrate, this is xn minus 1 dot, this is xn minus 1 dot equals to xn, again xn minus 1 dot integrate xn minus 2 dot, this is equivalent to xn minus 1, and again dot 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 x1 integrate, and finally x1, this is equals to z of t. So the feedback path x1 coefficient, what is the x1 coefficient? An, and this is minus, that's why this is an plus and minus plus minus minus. So this path x1 into an minus, again this path x2 into an minus 1 minus, and this path a2 into this is the a2 into xn minus 1 minus, and this is equivalent to a1, this is the a1 term, a1 minus a1 into x1, so this is the xn, so this is xn, this is a1 multiplying a1 xn plus and minus, so xn dot equals to minus an x1 minus an minus 1 x2 minus an minus 2 x3 minus an minus 3 x4 minus dot 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 minus a2 xn minus 1 minus a1 xn plus u of t. This is the state diagram, general block diagram of a linear system model. And state matrix, what is the state matrix? x1 dot equals to only x2. So this is the x2 value, because 0 into x1, 1 into x2, 0 into x3, 0 into x4, dot 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 0 into xn. And x2 dot equals to x3, only others value 0. x3 dot equals to only x4, and x4 dot equals to x5, and xn dot equals to coefficient minus n minus 1 minus n minus 2 minus an minus 3 minus an minus 4 dot 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 a1, and output equation 0 0 0 0 0 u of t. This is the state matrix. This is the state matrix from, and this is equivalent to x dot equals to x plus bu. This is the state equation, where x dot equals to x1 dot x2 dot x3 dot x4 dot 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 xn dot, and a equals to this special type of matrix, because last row only negative coefficients and super diagonal 1 and others terms 0. This type of matrix is called companion form, and x equals to x1 x2 x3 dot 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 xn, and b equals to 0 0 0 dot 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 1, and u equals to u of t. This is the state matrix, x dot equals to ax plus b of u. And what is the output? Z of t equals to only x1. Z of t equals to only x1, because this is the position and others value always 0. That's why z of t equals to only x1, 0 into x2 plus 0 into x3 plus 0 into x4 plus dot 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 0 into xn. And this is equivalent to output equation y equals to cx plus du. Y equals to cx plus du, where c equals to 1 0 0 0 0 dot 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 0, and x equals to x1 x2 x3 dot 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 xn. This is the state matrix form. The output is given by, so second part, ys by zs. Second part, what is the second part? Already proved zs by us. And second part, second case number 2, ys by zs equals to b0 s to the power n plus b1 s to the power n minus 1 plus b2 of s to the power n minus 2 plus dot 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 bn minus 2 s square plus bn minus 1 s to the power 1 plus bn. This is the second part, ys by zs. So calculate y of t or y of s. So multiplies. First multiply zs into beta b0 s n, zs into b1 s to the power n minus 1, zs into b2 s to the power n minus 1, zs into bn minus 1 s square s to the power 1, zs into bn, and ys equals to y of s. Y of s equals to this term. Taking inverse Laplace transform, and we get first value beta b0. This is the b0, and this is the nth order differential equation. So dn zt by dtn d to the power n plus b1 second coefficient s to the power n minus d to the power n minus 1 z of t d t to the power n minus 1 plus b2 d to the power n minus 2 z of t d to the power n minus 2 plus dot 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 bn minus 2. This is the second order differential equation, d2 zt by dt2 plus bn minus 1 s to the power 1 zt s to the 1 zt first order differential equation. That's why d of zt by dt plus bn zt. This is the nth order differential equation. Again, y of t equals to output and z of t equals to input. Here for second block, z of s equals to input, and this is the output, final output. This is the final output, y of s. So calculate y of t or y of s. Realization of the transfer function is now straightforward. The output, now the state variable form, the output equation is y of t equals to b0 x dot n, or nth order differential equation, plus b1 xn plus b2 xn minus 1 plus dot 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 bn minus 2 x3 plus bn minus 1 x2 plus dot 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 bn x1. Just put here z equals to x1 and z dot t equals to x2, z double dot t equals to x3, z triple dot equals to x4, and z n dot equals to xn dot. And this is the final block diagram for direct decomposition method. For direct decomposition method. Already lower portion discussed, upper portion. What is the upper division? First b0 x to the xn dot. So this is the xn dot, this is the xn dot into b0. This is the forward path. And second, xn into b1. So b1 into xn, this is the summing point. And third part, b2 into xn minus 1. This is the xn minus 1. From this point, b2 into the, from this node, xn minus 1 into b2, again add, plus dot 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 bn. This is the bn into, this is the x1. So y of t equals to this, y of t equals to b0 xn dot plus b1 xn plus b2 xn minus 1 plus dot 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 bn into x1. This is the output, final output of the direct decomposition system. The overall block diagram of the direct decomposition method. And y of t equals to what? b0 xn dot plus b1 xn plus b2 xn minus 1 plus dot 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 bn x1. Then put xn dot, put here xn dot. Put here xn dot equals to minus a1 x1 minus a n minus 1 x2 dot 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 plus u of t. Put here xn dot and we get, so b0 into xn dot equals to this equation. Put here minus a n x1 minus a n minus 1 x2 minus a n minus 2 x3 dot 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 u of t, and others value same, b1 xn plus b2 xn minus 1 plus dot 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 b n x1 e1 x1. So multiply b0 and common, so they get again multiply by b0. So minus an b0 x1 minus an minus 1 b0 x2 minus an minus 2 b0 into x3 dot 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 b0 into u of t plus b1 xn dot 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 bn minus 1 x2 plus bn into x1. This is the form. Then common x1 x2 x3 dot 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 xn. So x1 into, this is the minus an b0 into x1, and last term bn x1. So common x1, bn minus an b0. Similarly x2, this x2 and this x2 common, bn minus 1 minus an minus 1 into b0 dot 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 b1 minus a1 x b0 into xn, common xn. This is the xn term. This is the xn term, and this is also xn term. So xn common, b1 minus a1 b0, b1 minus a1 b0. This is the a1 b0. This is the a1 b0 into xn term, this is the xn term, plus b0 into u of t. So just common x1, x2, x3, x4 dot 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 xn, and last value b0 into u of t. This is the b0 into u of t terms. Then matrix form, output of the matrix form, y of t equals to bn minus an b0, bn minus 1 into an minus 1 b0 dot 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 b2 minus a2 b0. This is the coefficient, this coefficient, this coefficient, this coefficient, this coefficient, this coefficient, this coefficient dot 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 x1, x2, x3 dot 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 xn. Just multiply this into x1, this into x2, this into this into xn. Again this term return, and finally the 0 0 0 0 0 dot 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 b0 into u of t. So this is the final block diagram. This is the final block diagram. Just u into b0. This is the u into b0. This is the u into b0. And xn into b1 minus a1 b0. xn into b1 minus a1 b0. And xn minus 1. This is the xn minus 1 into b2 minus a2 into b0. This is the b2 minus a2 into b0 into xn minus 1 plus minus dot 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 dot. This is the x1 into what? x1 into bn minus an into b0, bn minus a1 an, bn minus an into b0 into x1 equals to y of t, y of t. So this is the overall block diagram for direct decomposition technique. So this is the overall block diagram of the direct decomposition technique, and this is the signal flow graph. It's simple, just simple. This is the u of t or u of s input, and this section y of t or y of s output, y of s output, n number integration, nth order integration. That's why n number summing point and n number integration. Just this is the b0 path, b0, and second part b1 minus a1 b0. This is the b1 path. This is b2 path. This is bn minus 1 path, and this is the minus a1. This is the minus an minus 1. This is the minus a2. This is the minus an. This is the SFG graph. Already discussed this portion, signal flow graph, and this is the final actual signal flow graph, total signal flow graph without xn dot, Previous signal flow graph with xn dot, and this is without xn dot, because b0, this is the b0, this is the b0 path into u2 yt, b0 path, and second part b1 minus b0 into a1, b1 minus b0 into a1. This is the second path. This is the second path, and this is the b2 minus b0 into a2. This is the third path, and finally y1s, bn minus 1 minus b0 into n minus 1. This is the x1 coefficient terms path. And lower question already discussed, a minus 1 minus a2 minus a3 dot 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 minus an minus 1 minus AN. So this is the overall signal flow graph without X dot and previous signal program with X dot. That's why B0 and signal flow graph of the systems. The state and output and equation is shown in below. This is the output. X dot equals to AX plus B ut, YT equals to CX plus DUT, where A equals to this matrix and B equals to 0, 0, 0, dot, 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 1 matrix, and C equals to minus Bn minus AN B0, Bn minus 1 minus AN minus 1 B0, dot, 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 B1 minus A1 B0. This is the C, and D equals to B0. This is the important value. That means multi-input, multi-output system. This is D. D equals to B0. If the direct path through B0 is absent, the reference figure, then the scalar D is 0. Already discussed. If B0 is absent, then D also absent, because D equals to B0. And the row matrix C contains only the BI coefficients. Only the BI coefficient. This is the figure. This is the figure. If B0 coefficients absent, only this path, and this path. So the matrix A has a very special structure. The coefficients of the denominator of the transfer function preceded by minus sign from a string along the bottom row of the matrix. The rest of the matrix is 0 except for the super diagonal terms, which are all unity. In matrix theory, a matrix with this structure is said to be the companion form. For this reason, we identify the realization as companion form realization of the transfer function. We call this is the first companion form. So matrix, what is the matrix form? This is the matrix form. Last row only minus coefficient, and super diagonal only 1, and others coefficients all zeros. This type of matrix is called companion form matrix. Thank you.